Hello everybody, welcome to Alexa's Lead Code. Excuse me. Where we do programming problems together on stream. Excuse me. I'm sorry, I have a terrible cold for a few days. I had a sore throat and I've been wondering whether I should go to the doctor or just wait for it to clear up. But I think I'm gonna have to see the doctor soon. Alright, back to programming problems. So today we're going to work on an easier problem than we normally do. Because the last time we worked on, I think for the last couple of weeks, we've been doing really hard problems. So today we're going to switch to an easy problem. So we never got around to finishing the sort list from last time. But that's okay. We're going to work on a new problem called Palindrome number. And if we have time later today, we'll go back to sort list and finish that off. So Palindrome number, it's an easy rated problem. It has 55% accept rate. So hopefully this will not take us too long. Alright. I need to get my chat. Give me a second. Okay, I got my chat up. Okay, now I think I can see my chat. I swear, it's gonna be better than last time. Okay, so as usual, let's start with reading the problem. It says, given an integer x, return true if x is a palindrome and false otherwise. So a palindrome is a number that reads the same backwards and forwards. So it says here integer. So I assume that like like 1.123.321. This is not something we're gonna get. which does make things a little bit easier. So examples, x equals 121. Yes. X equals minus 121. False. Okay, interesting. I think this also means that any negative number is automatically not a palindrome. Any negative number is automatically disqualified because of the minus sign. So we can check for that right away. In fact, let me write that down. Any negative number is not a palindrome because of the minus sign. And finally, with x equals to 10, which is false, since it reads 1 0 and from the back it reads 0 1. Okay. Could you solve this without converting the integer to a string? Yes. I wasn't planning to convert it to a string, but we can solve it. Okay. So how do we test? How do we test that a number is palindrome? Well, the first thing I have in mind is given a number, if the two ends are the same. Hold on, actually give me a second. I'm going to try doing something. I'm going to see if I can set up a second screen to see the chat. Okay. Cool. Got it. Oh, I can put people in timeout. But it's only me here, so I need to put myself in timeout. Ah, I see. So high latency mode is tricky. Low latency mode. I also noticed that my picture quality is extremely low. Okay. This is soft for now. Let me also switch to dark mode. Okay, cool. This looks a little bit better, right? This looks a little bit better and a little bit easier to see. Okay, awesome. I'm going to keep these settings. Let me know in the comments if this is better or worse. Well, we'll find out. All right. So, back to the problem. Sorry, I'm just constantly being distracted. Back to the problem. It looks like, I think the way to think about this is I want to look at the first and the last number. First and last number. First and last digits. If they are different, then it's not a palindrome. If they are the same, then, well, then we check the rest of the number. So I'm essentially reducing this to sort of a recursive problem, but as usual, I'm always skeptical about using actual recursion because of limits on recursion depth. So I'm probably not going to write this in a recursive way. And then, of course, the base case is has one digit or zero digit, i.e. is you can't have a zero digit number. Okay, cool. Okay, so this works. So let's see. Let's start with the things that we know first. So first, we handle the negative number. We're essentially translating what this pseudocode we've written. We are translating this pseudocode we have into actual Python. If x smaller than 0, return false. Okay? Otherwise, we're going to do something and we're going to repeat this. Okay. So this is the tricky part. We need to get the first and last digits. Oh, not yet. Before that, if x is smaller than 10, return true. So if x is smaller than 10, it means that it's a single one-digit number. Since we have already established that x is at least 0. If x is smaller than 100, it means a two-digit number. Return true if x, okay, this is, if x is divisible by 11. Yeah. So this is a bit of a mathematical trick. Basically, what this here do, what this thing over here does, is it checks if x is a 2-digit number where the check if x is 11, 22, 33, etc. And the easiest, fastest way to check this is just, see if it's divisible by 11. If it is, then it's true. If not, then it's not. Right? And this works for numbers up to 99. This is just a clever pattern that we notice. Okay. Alright. So now we get the first and last digit. First and last digits. How do we do this? The last digit is actually pretty easy. So last digit, we take x, we take the remainder, by 10. So we take x divided by 10, and we get the remainder. So this percent is modulo. And if we take x divided by 10, take the remainder, then that gives us the last digit. That's easy. How do you get the first digit? First digit is a bit trickier. First digit is indeed trickier. I'm thinking, is there a mathematical way to do it? Well, there's a like a hacky way, sort of unfair way to do it, which is convert it to a string. And now I'm very tempted to do it. How do you get the first digit from a number? Okay, I gotta think a little bit about this. The first digit from a number. So let's say the number is right here. 1, 2, 3, 4, 5, 4, 3, 2, 1. Well, one thing I can do is to divide by 10 until I get this digit over here. But that seems annoying because that seems kind of annoying because I will have to do this a bunch of times. And I repeat that every single time. Okay, so there are few ways that come to mind. None of them I like extremely much, but maybe I'll just pick one of them. So there are few ideas that come to mind. One, I'll keep dividing until I reach a 1-digit number. So I'll do something like equals to x divide 10. While first digit is larger than 10, first digit equals x divided by 10. Okay? So this will give us what we want. So this will give us what we want. But I find this a little bit annoying because this means we have to, on the first sort of layer of the onion, we have to divide by 10 7 times. And then a second layer will divide by 10 6 times. 5, 4, 3, 2, 1, and so on and so forth. And that just annoys me a little bit. That just annoys me a little bit. And that just annoys me a little bit and makes me think, okay, why don't I just turn x into an array of digits? A list of digits. Why don't I just turn x into a list of digits and then deal with the list? Isn't that easier? Maybe it is. I'm a little bit unhappy because I was hoping I can do like both of these mathematically. Then I never had to do the conversion. Maybe there is a way. Okay, you know what? Let's do a thing first. Let's finish the problem using whatever way possible, and then we think about making it better. Alright, so last digit equals to x ampersand 10. So x divided by 10. First digit equals, keep doing this until first digit is, we get the first digit. Oh, why is this slightly off? If last digit not equals first digit, return false. Otherwise, just return the inside part. So this is again annoying because it's hard to do this mathematically. Okay. So dealing with the first digit mathematically is a pain. Okay. Okay. So I'm going to use this same while loop to keep track of the middle part, because I need to figure out what the middle part is. Equals. So let's see. So I want to calculate the middle part, right? So I have something like 1, 2, 3, 4, 5. So during this cycle, during this loop, first equals to 1, 2, 3, 4. Middle equals to 5. Okay, so I want to just repeatedly divide by 10. So second time x equals 1, 2, 3. Oh, it's wrong. Okay. So I want this to be x slash 10, yeah, correct. And then this is x percent 10. first digit equals to first digit slash 10, not x slash 10. So that would make first digit 1, 2, 3. So basically I want this while loop. Why I'm doing this while loop is I'm playing a game where I want to shift digits from here to here. I want to get this. This is what I want to get next. So middle equals to middle plus, I need to do this first. First digit ampersand 10 times 10. Okay. So each time I want middle to be the sort of right side of this. So let's say first digit starts off as 1, 2, 3, 4. Middle is 5. I want to move this digit 4 from first to middle. So middle will be first ampersand 10. Take the remainder of first divided by 10, which gives me 4. And then multiply that by 10. And I add it to middle. Oh, wow, this is getting to be annoying. You know what? This is super annoying. I'm gonna just put everything in an life should not be this difficult. Okay. We're gonna cheat a little bit. Okay, we're gonna change tag. Put digits into a list. So we're gonna put the digits into a list and deal with the list. I thought that I could just deal with the number numerically and be done with it, but apparently it's much harder than I imagined it to be. So we're gonna do it slightly differently. We're gonna say step 1, put the digits into a list, and then step 2, just check if the list is a palindrome, which is much easier than checking this number. All right. So digits. So first thing we're gonna do is to put this in a list. So we say digits equals empty list. This should be fairly straightforward. While x is larger than x, we take the right hand side. Apparently it's much easier to get the last digit of a number than the first digit. I'm going to think about how to get the first digit later on. I'm sure there's ways to do it. Okay, so digits dot, is there a list prepend? How do I prepend to a short Python list? Insert 0. Okay. 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 Let's move things a little bit around. I want this to divide by 10 first. So I'm going to start by inserting the last digit while x is larger than 0. Yeah. Okay, while x is larger than 0. I want to delete this. Okay, so what we've done here is we start by saying we create a list digits. We put into the list one thing, which is the smallest digit in x. So we take x, we take the digit on the right hand side and we stick it into a list. And then we say while x is larger than 0. Oh, actually this will not work. You'll have an extra insert at the end. So let's start with this instead. While x is larger than 9, digits dot insert 0, comma x. And then when x dot insert x. Okay. So what this will do is it'll say if x is larger than 9, if x is larger than 9, then we insert the rightmost number into digits at item 0. So we insert always to the left. And then we reduce, and then we divide x by 10, we'll drop the last rightmost digit. Okay, alright. I think this would just give us a list of digits. So now, this is fairly straightforward. Right? While digits. So we basically do the same thing as before. Length of digits larger than 2 larger than 1. So if x is a 1-digit number, then we're done. If there's no digits left in the list, we're also done. We're gonna check. First equals to digits 0. Last equals to digits minus 1. Okay? So there are a few ways we can do this. One, we can say length of digits minus 1. This will give us the length of the list, and we might we subtract 1, that will give us the index of the last element, and this will give us the index of the last element. But in Python there's a shorthand. If you say digits minus number, if you pass in a negative number, and it'll start counting from behind. So in this case it will just do last digits minus 1. Okay, cool. So if first not equals to last, oh my god, check this out. All this frustration and all this trauma and turmoil, love lost and found, so much easier when I do this. Oh god. Alright, first not equals to last, return false. Right? If first not a digit, last digit is different, then it's clearly wrong. Otherwise, digits equals to digits 1, comma, minus 1. 1 colon minus 1. So this is slicing. I'm pretty sure this will work. And this 1 colon minus 1 will give us, will take a list. So digits now is a list, like 1, 2, 3, 4, 3, 3, 2, 1. It says start from item 1, which means this 2 over here, and go to my item minus 1, which is this 2 over here. I think actually it should go to minus 2, I think. Okay. Minus 2. I think it's like this. I'm not sure. Okay. As usual, it's fine to be not sure. All you do is to run it and find out. Alright. Okay. Return true. I think that's it. Let's run it and see what happens. Oh no, not a pen, pre-pen. 0, x. Where is this? Oh, digits. Colon -2. Run. Okay, so it passes. Case 2 passes and case 3 passes. Okay. And let's try submitting. Oh, we haven't. Wow. I think this might be wrong. Let me see. Okay, as usual, we're gonna whip up our trusty Python tutor. Edit code and get AI help. And get AI help? That makes it a little bit suspicious. What do you mean by edit code and get AI help? So x equals this number. Oh, actually, because I have return statement, I need this. Okay, so we are going to call is palindrome. Get rid of the self. Is palindrome x. Oh, there's more that I'm not. Okay, visualize execution. Okay. Is palindrome this? Okay. Okay, this one I want to zoom a little bit less. Next, digits empty lists. Okay. While digits larger than 9, 2, you see how we're slowly inserting. Oh, yeah. So we're slowly inserting digits on the left of this list, and x is shrinking. Okay, so we want to check that our digits list is correct. 1 0 0 0 0 2 1 1 0 0 0 0 2 1. Okay, so our digits list is correct. So first equals to 1. Okay, last equals to 1. Okay, cool. First and last, nope. Digits equals to the middle part. Oh, that's not right. This should not. This took 2 things off at the end. Okay, edit code. That's not right. This should be -1. Let's try it again with -1. Submit. Okay, cool. Now we're done. And we are done. Okay, so notice our memory usage is higher than a lot of other users. So I'm wondering if other people actually the reason why we use memory is because we created this digits list, which takes up extra memory. I wonder if other people actually use less memory because they did the mathematical approach. Yeah, you see this runtime, it's not very accurate because it fluctuates quite wildly. The first time I ran it, I beat 70% of the users, and now it's slower and slower. Why? Okay. So that's it for today's problem. Now, this is, I think, the most interesting part of the problem. this is like a Pythonic or like idiomatic way of slicing an array. Right? This says go from 1 all the way to -1. So I always get I actually always forget whether it's -1 or -2. -1, when you do it this way, gives you the last element of the list. So I'm guessing that means until -1 just means up to the last element -1. So it's sort of like length -1. So I think that makes sense. If you want to go from the first or index 1 all the way to the end, all you have to do is to drop this. This will give you everything except the first element. Likewise, this will give you everything except the last element. I think that's the most important, most interesting part of today's problem. Okay, cool. Since we have a bit of time, we are going to change tack. So for those of you who are only interested in today's problem, you can sign off right now. But I am going to change tack back to solving the problem from last time, which is sort list. So remember sort list? It's this thing over here. Just as a quick refresher, we are given a linked list and we're trying to sort this. And the way we did it is we end up writing quicksort on the linked list, which is kind of cool. I never thought about writing quicksort on the linked list before, but there's the bug. Let me see if I wrote notes on what the bug is. Nope, I did not write notes. Good job, last week's self. But let's run it and see what the problem is. So there's some kind of bug here. Time limit exceeded. Oh, okay, I remember. So it's functionally correct, but somehow there's a reason our linked list, our solution fails when there's a very large number of for a very large linked list. Okay, let's see. Let's do a refresher to see what we're doing. So we have head as the fulcrum. Mid value equals to head dot value. Mid equals head. Okay, so far so good. Before and after. Excuse me. Okay, before last, after last. Oh, I remember this part. So we're basically going to break. We take the first number as a fulcrum. This is a reminder to you guys as well as to myself. Okay, and then we'll take all the other numbers and put them under the fulcrum, based on whether they are on the left or on the right. In this case, everybody smaller than 4, they all go on the left. And then what we have, so that's this part over here. So I should comment my own code. Put items into either before or after. Okay. So once we've done that, O iter equals iter. So what are we trying to do here? We are trying to set. What are we trying to do here? Oh, set the next of. So set next to none for current item. Okay, so we take the current item, we set the next to none. Okay, so every item we put it either on the left or on the right, and then we set its next to none, because we want to sort of like, I want to say like cut it off. I don't know if that term makes sense, but we're sort of like cutting it off. We're snipping it off. It doesn't really matter as far as correctness goes, but it looks so much better when I stick into Python Tutor. Okay, alright. So before, after. Okay, before and after. Oh, somebody just joined the stream. Oh, I can't see who it is. Hi, person who joined the stream. Welcome. Welcome, welcome. Um, we were doing an easier problem before, and when we finished it, so now we are going back to our old problem from a couple of days ago. The sorting of the linked list. Moving forward, I'm going to try and do more easy problems. I think I got feedback that some of the problems we are tackling over the last couple of weeks are really difficult, and people are having a hard time following along. So we're going to do easy ones for a while. Hopefully, there's still some learning objective during each of these easy problems. Okay, so we got before and after. We sort the before and after, and then we stitch them together. Okay, so what was the problem with this? I can't remember. I can't remember what the problem was. I think it has to do with this before and after. This thing is actually pretty slow. Let me see. Did I run out of time or memory? Okay, I ran out of time. Why is it slow? Okay, alright. So I have 1. Everybody is going to go on the after. I wish I had taken notes from last time. Okay, everybody is going to go on the after. And that's fine. We're going to get a big array. So we did it recursively. Which makes me think that we've exceeded recursion depth. But maybe we've not, right? Is this... Oh, this is huge. Oh my god. So maybe we have exceeded recursion depth. Maybe that's the part that we have to deal with, okay? So we did this recursively. So recursion is great so long as you know how deep your recursion is going to be. If you're going to use recursion to go through an entire list, and the list looks something like this massive list here, then I bet that what happened was we just exceeded the recursion. This is huge. Wow, this is huge. Okay, I'm pretty sure this exceeds the recursion depth. So let's do a thing. Let's rewrite this, but instead of making it recursive, we're gonna make it iterative. That's what we're gonna do. We're gonna make it iterative. So before and after, self.helper before. So before I can stitch, let's see. So I've got my fulcrum. I'm gonna think about here, and I'm thinking along with you guys. So we have a fulcrum. We've sorted things into A, sort of before and after. Alright? So our next step is to connect this to this, and this to this. But I don't know what the before and after are on these guys. I need their before and after before I can actually connect them. So one thing I'm thinking. This is a terrible idea. I'm just gonna think aloud here. This is a terrible idea. I'm gonna keep a list, right? So one of the most common ways to turn a recursive solution into a non-recursive solution is to keep a list. Is to keep this like to-do list. So as you instead of making a recursive call, you add to the to-do list. You add to the to-do list, and then you have some kind of while loop here that goes over the to-do list. Your to-do list starts with the first one. Then it gets really complicated. I mean, like I can do this, but it gets really complicated fast. I am stumped. I mean, I could do this. We could say, this to-do list is to sort the whole thing. And then I have to sort the before and the after. And then put them back into in the to-do list. And at the same time, I do maintain a separate to-do list. This is annoying. So I have a to-do list that says these are things I want to sort, and I have before and after. So first I start with like head, and then I'm done. I have before, and I have after. And then at the same time, I keep a separate to-do list that is about, like, I need to keep this step, this like merging step in the to-do list also. This is kind of annoying. Let me think about it for a few more minutes. And if I can't think about it, if I don't come up with anything, then we're gonna punt it for next time. Let's see. This is tricky. So I think the problem is, I think the reason why we are failing this giant test case is because this thing is recursive. And we sort of exceeded the recursion depth. So we want to turn this into an iterative strategy. Okay, put things into before, after. Actually, we can put it in a list. You know what? We can put in a list. But no, we shouldn't. I'm going to do something. Here's what I'm thinking. Okay, we're going to put this into a stack. Okay, so this is going to get really advanced. A stack. A stack. So the way a stack works, a stack is a data structure that looks like this. Okay? It's, it's ostensibly a kind of list, but the rules of a stack are, if you put something in, the last thing that you put in is the first thing you take out. So think of like a stack of dishes. If you you stack up a bunch of like books, right? So, you put these things 1, 2, 3, 4, 5. So the thing you take out first will be number 5. So a stack is a data structure where the first thing you take out is the last thing you put in. So you sort of take things out in reverse order. So I'm thinking of a stack solution. And it's going to go a little bit like this. Okay? we start with head. So we have this 4 here. Okay? This will be the bottom of our stack. We're going to take this 4. We're going to turn it into before and after. Okay? And we're going to do this. We're going to turn it into 3 things. We'll have the fulcrum here. We still have 4. So we have after. And then we have before on the stack. And then now we say, hey, let's sort after. Okay? Now we sort after. Oh, this is actually not a bad idea. This is actually not a bad idea. This might produce really, really complicated code. And I'm kind of curious what other people have done. But this might be the way I'll try to solve it. Okay? This might be the way I try to solve it. I don't mind producing complicated code, because the point of this channel is to teach you how to program. It's not to teach you to memorize clever solutions or elegant solutions to special problems, right? If we end up writing something that is fairly complicated, that's fine. Because when we program in real life, production code is often complicated. And writing a complicated solution right now will give us practice in writing a complicated solution later on. So that's totally fine. I'm okay with not getting the most quote-unquote elegant way or smart way of doing things. And I feel pretty strongly that should be the point of leak code problems. You shouldn't be looking for clever ways. You should be looking for good engineering ways of doing things. Okay, so here's what I'm thinking. I got a stack like this. And the idea is every time I'll take the top guy out. Okay, let's restart. So I've got a stack like this. At first, what I have is head. Okay, so each step of the stack, I'm going to take the top guy out. I'm going to take out the top person. Okay, so I'm going to take out the top person. So it starts at head. I'm going to make him my fulcrum. I'm going to have before and after. Alright? So basically all the code I've written here, I put things in before, put things in after. And then what I'm going to do is I'm going to say, hey, okay, let's put these things back into the stack. And I'm going to put them backwards in like forward order. So before will go in first. And then the head. And then after. Okay? And then now, I take out after again. So I take this guy out. And I make him the fulcrum. And I do his before. And his after. Alright? And then I push them back in. So this will be A before, this will be A, and this will be the after of A. Okay? And I keep sort of expanding this. Except when I take something out, okay? When I take something out and it's just one element, then I'm done. Okay. So, okay, I like this strategy. This is so complicated. This is so complicated, but I am going to draw it out and I'm going to see if you guys get it, okay? So, first, I'm not going to do this today. First, I have 4, right? Sort 4. So 4 is over here. So 4 is like 4, 2, 1, 3. Okay? So I'm going to say sort 4. I'm going to take out 4. I'm going to remove it from the stack. 4, 2, 1, 3. I'm going to separate this into before, fulcrum, and after. So my before is actually 2, 1, and 3, right? 2, 1, and 3, they're all in before. And my after is empty. My middle is 4. That's my fulcrum. Okay? And so what I do here next is I'm going to take, again, I'm going to take out the top element in the stack. Yeah. I'm going to take the top element out. It's empty. So I say result plus, so I add empty to result. So result is now empty. Okay. So now I take 4 out of the stack. So because 4 is a single element, I'm going to result equals to 4. Okay? And I don't do any more sorting since it's only one thing. And now I had 2, 1, 3. Now I get 2, 1, 3 out of the stack. Okay, I think this should work. So 2, 1, 3, I make 2 the fulcrum because it's the first number. I sort them 1 and 3. Okay? I take this 2. I put these things back into a stack. So this will be 1, this will be 2, and this will be 3. Okay. Oh, actually, I should do this backwards. I should do this. I should be 1, 2, 3 instead of like 3, 2, 1. Okay, gotcha. So I take the first item here, 3. I pop it. Since 3 is a single element, and know this because 3's pointer is next pointer is nothing. I'm going to add 3 to result. And now 2, same thing. 2 is a single element. I'm going to add 2 to result. And then 1 to result. Okay, so this is how I'm going to do it. Excellent. I'm not going to do it this time, but I am going to keep extensive notes so I won't forget my strategy. Update 12.2. New strategy. New algorithm. For removing the recursive call, use a stack. Iteration. Push the before fulcrum. Actually, it's after first. Push the after fulcrum and before into the stack. onto the stack. Okay. Pop the next thing in the stack and repeat. If the next thing in the stack is a single element, then add to head. Interesting. So this is what I'm doing. So maybe instead of using quick sort, I'm gonna just do this. I'm gonna think about it a little bit. Okay, all right. I think we're good to go. So that's all I have for today. As a quick recap, we managed to solve palindrome number. That's number 9, and we also have, well, I think I have a new strategy for hunting swine, white whale, which is a little bit annoying because it's not supposed to be this difficult. So let's pick up. I'm sorry, guys. I hope that didn't appear on the mic. Let's pick out our problem to solve for next time. Let's pick an easy problem again. Graph. Wow. None of these are easy. Divide and conquer. Okay, search insert position. That requires binary search. Let's do an actual easy one. Remove duplicates from sorted list. Okay, so this will be our next. Non-decreasing order, remove duplicates in place. Return the number of unique elements. Okay, this is not too difficult. So let's do this problem next time. Remove difficult duplicates from sorted list. I'm gonna put them in my stream details. All right, so that's it for today. Thank you everybody for tuning in, and see you next time. Bye bye.